Hello, what's up guys? So this is day 2 of our programming journey, and in this video I'm going to talk about the execution process of the Java program. Alright, before that we need to understand the working of the compiler and the working of the interpreter. Okay, so the compiler takes the entire program as its input and produces the intermediate code or the executable file or the machine code for the same. Okay, so this machine code consists of zeros and ones, and whenever we try to run this machine code or the executable file, we'll be able to see the desired output. Okay. Now, in case of the interpreter, interpreter takes line by line input and produces line by line output for the same. For example, for this line, interpreter will translate and produce output as this line. All right. Interpreter does not produces the intermediate code. Okay, so if we try to like delete this file, we won't be able to get this output. However, that is not the case with the compiler. Even if we try to delete the source code and we still have this executable file, we'll be able to see the desired output whenever we try to run this executable file. Alright. Now, in case of the compiler, for example, there is an error in the line third. Okay. Now, during the compilation process, as the compiler would encounter error on the line third, it won't produce this executable file. It will simply stop the compilation process and produce the error for the same. Alright. Now, in case of the interpreter, so if we encounter error on this line, okay, that is the third line, the interpreter will still produce output for these two lines, okay, and whenever it will encounter this line it will throw an error over here and it won't produce the outputs ahead. For example, it won't produce output for this line. Okay, so now let us talk about the execution process of the Java program. So the Java program mainly goes to two phases, that is the compilation phase and next is the interpretation phase. Alright. In the compilation phase, the compiler is used, and in the interpretation phase, the interpreter is used. As both the compiler and interpreter are used, Java is also known as a hybrid language. So first thing first, let us focus on the compilation phase. In order to write any Java program, we have to save it using the .java extension, and then we have to compile it. For compiling the program, we have to type the command javac space the program's name. Now this javac invokes the Java's compiler, which in turn checks for any compile time errors and produces the bytecode. We have already seen what type of compile time errors there are and like how this compiler works. Alright, so this bytecode which is produced by the compiler is not the machine code, that is, it does not consist of zeros and ones. It is an intermediate code which is only understandable to the JVM. Now, JVM sits in between the operating systems and the program in order to communicate and use the resources of the OS. Alright. So also this bytecode is platform independent. That is, this bytecode can be run on any machine now. That is the machine using Windows or Linux, etc. And this is because of the JVM present. So there are different JVMs for different machines. Okay. I'll give you the brief about this in the next video. Alright, so let us just focus on the execution process of the program. So as we have seen, this bytecode is platform independent. Alright, so in order to run this bytecode, we have to type the command as java space the bytecode's name, that is ABC. After that, the JVM comes into the picture and it has three main components inside it. First is the class loader, which loads all the necessary files, all the necessary classes which are used during that program. For example, if a person has imported another class from a different directory, so that class would also be included over here, and all the other classes necessary for the running the program. Now, after all the classes have been loaded, it will be passed on to the bytecode verifier. The bytecode verifier would verify the bytecode, check for its integrity if the bytecode is proper or not, and then pass it on to the interpreter. Let us just exclude this step for now. I'll shortly explain you what this is. After that, the interpreter will produce line by line output for the line by line instructions inside this bytecode. Alright, and then it will pass on to the operating system, and the operating system will show the output in our screen. Okay, so this was all about the execution of the Java program. Now let us talk about the JIT and what this is. So JIT stands for the just-in-time compiler. Alright, let us look into two cases for understanding the working of the just-in-time compiler. So consider this program as the input to the interpreter. Alright, so as you can see, these two lines are exactly the same and they can be termed as the redundant lines. Okay, so even if we ignore one line, there won't be any change to the output. Alright, so there won't be any, like, the output will still remain the same. Okay, since we are just defining a variable b is equal to 7 twice. Okay, so in the first case, the interpreter will produce output for the first line, that is this one, this thing, and for the second case, the output would be this line, and so on. And now whenever the interpreter would go to this line, that is b is equal to 7, the interpreter would translate and produce the output, that is this line. All right, now again the interpreter would go to the next line, that is b is equal to 7, and produce the same output. All right, now as you can see, this output has been produced twice. Okay, so there was no need to produce this output again. All right, so to stop this, to stop this problem, the JIT comes into the picture. JIT stands for the just-in-time compiler. That is the compiler compiles the program just before it is passed to the interpreter. Therefore, the term known as just-in-time compiler. Now this just-in-time compiler checks for the redundancy in the program, and during checking, it will find out that this has been written twice, and even if we remove this, there won't be any problem to our output. All right, so JIT compiler simply discards this line of code and passes only these four lines to the interpreter, and accordingly interpreter will produce only four lines of output for the same. And as this line was discarded by the just-in-time compiler, the output won't be produced for this line. All right, so thus saving time for us and improving the efficiency of the program. Now let us take an example that if there are 1,000 lines of code over here and 500 of them are redundant. Okay, so the JIT compiler would would increase the efficiency of the program by 50%. That is, as 500 of them were discarded by the just-in-time compiler, only for the remaining 500, that is the non-redundant ones, the output would be produced. Okay, so this was all about the working of the program. I would like to add one more thing to this working. All right, so this bytecode which is produced by the compiler is actually the dot class file, and this is some gibberish code. This is not understandable to OS. That is, it is not a machine code. That is, this does not consist of zeros and ones. Okay, if it would have consisted of zeros and ones, it would have directly understood by the OS. Okay, so this bytecode will be sent over here to the JVM, and to the and JVM's and the input of the interpreter of the JVM would be the bytecode, and for the this bytecode, the interpreter would produce line by line output. That is, it would produce line by line machine code. All right, so that it can be executed by the operating system. Now, one more thing I wanted to talk about. This just-in-time compiler is not always invoked. Okay, it depends upon the making of the just-in-time compiler. Okay, some compilers are very aggressive and some are not so aggressive. Okay, it depends on company to company which are making this just-in-time compiler. All right. So this was all for this lecture. I hope you understood the concept, and please like and share my video. Thank you so much for watching.